Okay, so let V equal this. W equals A2I plus B2J. Okay. First of all, what then is V dot W? You should stop and do it. You should have already done it or done it in your head. And you see very clearly that this is, well, let's go ahead and use the notation. And we get A1, A2 plus B1, B2. There's our dot product, okay? So, how would you write out the magnitude of V? Should have written it out. And of course, you can pause when I say you should do this. You don't want to try to do it in the brief time I give you, although you probably can. V equals, magnitude of V equals what? Now, I could write down what it is by the Pythagorean theorem. It's just A1 squared plus B1 squared, square root of. But I'm going to the definition, because we want to get used to starting with definitions. You can't prove things if you don't start with the definitions. If you just start waving your hands, you might say a lot of good stuff, but I'm not going to regard that as a proof unless it's airtight, okay? You might have the idea of the proof, and on a test that would be worth something, but probably no more than half credit unless you are pretty rigorous with it, okay? So here's your magnitude of V, and that's just the square root of V dot V. Now I said I was going to stop writing out the row and the column, and I'm confident that you can do that now. You know, it'd be the row A1, B1, and the column A1, B1. And that's just going to be A1 squared plus B1 squared. And there's your Pythagorean theorem again, okay? Now, what if you go to 3 dimensions? Let's say that U equals 5I minus 7J plus 2K. What's the magnitude of U? Well, write that out. Work it out. Okay, you should have already done it. It's just U square root of U dot U. And U dot U, again, is just going to be 5, negative 7, 2 row, 5, negative 7, 2 column. It's going to give you 25 plus 49 plus 4 equals 58. No, it's not 58, it's 78. And it's square root of, okay? And what if U equals A1I plus B1J, and I don't have to even distinguish, AI plus BJ plus CK. What's the magnitude of U? Write it down or think it. You pause if you haven't done it, but hopefully you have. That's going to be what? Being a little more careful to write things out because we have now symbols. I write this out. Then if necessary, I write out the row and the column A, B, C, A, B, C, and I get the square root of A squared plus B squared plus C squared. Now we can easily prove, just using a little bit of geometry, that is the magnitude in a Euclidean space. Okay, the Pythagorean theorem just extends, and it extends into higher dimensions. You've got a vector with 4 components, it would be the squares of these 4, because that's how the dot product would work out. Row, column. No limit in how long the row, no limit in how long the column. So the question now is, how do you write that out?